So this problem is just another example of a mechanism problem. So first we have to classify our alcohol. Again, look at the carbonyl-carbon. You can see that it's attached to 3 other carbons. So this is a tertiary alcohol. Tertiary alcohols form tertiary carbocations, which are quite stable. So this is going to be SN1. And later we'll discuss how tertiary alcohols are actually not able to do the SN2 mechanism because the transition state is too crowded. So we are going to revisit substitution mechanisms in Chapter 8. So this mechanism is going to be an SN1, which gives us 3 distinct steps. The first one is identical to the first step in SN2, that's protonation. Our next step is loss of water, so sometimes that's called dissociation. And our third step is the nucleophilic attack step. So I'm going to redraw the alcohol, put my oxygen lone pairs in because that's where everything starts. So I start with the oxygen lone pair. We're going to form that OH bond, break the HCl bond. The electrons end up on the chlorine. Now I will draw the alkoxonium ion. My oxygen again has a positive charge because it only has 1 lone pair and 3 bonds. To balance that, the chlorine has a negative charge. So notice that on the left side of this reaction, it was neutral overall. It's still neutral on the right side. In the dissociation step, it only involves the alkoxonium ion falling apart. So I'm not going to draw the chloride ion at all, just know it's there hanging out. So in this step, the CO bond breaks and those electrons that were in the bond go onto the oxygen. That gives me my tertiary carbocation plus water. And there's my lone pair that was a bonding pair. And the last step is where the chloride ion comes into play. It's acting as a nucleophile and attacking the carbocation. That arrow is designating the carbon-chlorine bond forming using an electron pair from the chlorine. So that gives us our final alkyl chloride product.